This is practice test number 5, and we're working here on problem number 10. And the problem states, fill in the following table of possible decisions that you can make in any hypothesis test. Show which are correct decisions and which are type 1 and type 2 errors. So in this column we have the statistical decision that we could make. We could either fail to reject or do not reject the null hypothesis, or we could reject the null hypothesis. Those are the two decisions that we can make in the hypothesis test. And then over here we have the actual situations. In reality, the null hypothesis could be true, or the null hypothesis could be false. Now, if the null hypothesis is true and we do not reject it, then that's a correct decision. The hypothesis is true, we failed to reject it, that's correct. But if the null hypothesis is true and we reject it, we reject the null hypothesis, that's what we call a type 1 error. And then over here, if the null hypothesis is false and we do not reject it, it's false, but we do not reject it, that's what we call a type 2 error. And if the null hypothesis is false and we reject it, which is what we ought to do, then that is a correct decision. So you're going to be given a table like this, and you're going to be asked to fill in these different decisions in the table. Letter B asks, based on the previous example problem given in number 8, what type of error level what is the type 1 error level of significance? And that is the alpha level of significance 0.05. Question C asks, what problem is caused by a type 1 error? And the answer is a false alarm. For example, in the problem with the light bulbs, if we had a type 1 error, then we would reject the null hypothesis that the life of the light bulbs is no longer 7,500, it has changed. But the reality is, the actual situation is the null hypothesis is true, we made a type 1 error, and we think there's a change in the mean life of the light bulbs when actually there isn't, and that's a false alarm. And then for letter D, the question is, what problem is caused by a type 2 error? And the answer is a missed opportunity. In the example with the light bulbs, if we made a type 2 error, the null hypothesis would be false. And that would mean that the mean life of the light bulbs is no longer 7,500, it has changed, but we have rejected it. We haven't failed to reject the null hypothesis. We do not reject it. That's a type 2 error. And the mean life has actually changed, and we should address the problem, but we missed the opportunity because we did not reject it, and the null hypothesis was false. So a type 2 error causes what's called a missed opportunity. And then the last question is, if beta is equal to 0.15, what is the power of this test, or the strength? How accurate is the test? And the power formula is 1 minus beta. All you have to do is plug the beta in, 1 minus 0.15, and you get 0.85.